Let us see the next question. A study made by a mutual fund has revealed the following data in respect of three securities: security A, security B, security C. Standard deviation information is given to us. Correlation with index, that is R, is provided between A and M, B and M, and C and M. Okay, R is given between AM, BM, and CM. The standard deviation of market portfolio, that is BSE Sensex, is observed to be 15%. So sigma M is provided to us as 15%. What are the covariances among the various stocks? That is a question. So over here the question says that so you are required to compute the covariance between the returns of A and B, returns of A and C, and the returns of B and C. That is the question. I request all of you to go through the question, please. Let us have understanding that say how to make the calculation of answer. We understand that, say friends, over here that covariance between A and B, it is basically calculated by using a formula like this. That is R between AB into standard deviation of A into standard deviation of B. That is multiplication of this three is what we understand is the covariance. Because like I hope that everybody recalls a simple formula that we already have done for correlation coefficient. Correlation coefficient is calculated as covariance between A and B divided by standard deviation of A, standard deviation of B. That is what we understand. So we keep the covariance as it is, and standard deviation of A and B is transferred on the left hand side. So R into standard deviation of A into standard deviation of B. This is what we understand. Now listen carefully what I am going to speak. The question is providing the information regarding standard deviation of A 20%, yes. Standard deviation of B 18%, yes. Now the question does not provide the information about the correlation coefficient of A and B directly. However, correlation coefficient is provided between A with M and B with M. So what we will do, dear students, we'll make the calculation like this. R between AM into R BM into standard deviation of A is 20% and standard deviation of B is 18%. This is the way we are required to make the calculation of answer. So it is 0.60 into 0.95 into 20 into 18, that comes to 360. So what happens at say 0.6 into 0.95 into 360, that comes to 205.2. This is the way we can make the computation of the covariance between security A and security B return. Okay, this is the way the covariance is found between AB. Now covariance between A and C, it will be found as R between AM into R between CM into standard deviation of A into standard deviation of C. That is the way we are required to calculate. Correlation coefficient of A with M is 0.6, C with M is 0.75. So this is 0.60 into 0.75 into standard deviation of A 20, standard deviation of C 12, So this is 20 percentage and this is 12 percentage. 0.6 into 0.75 into 20 into 12. That comes to 108. This is the way the covariance is calculated between A and C. Next, covariance between B and C. It will be R between B with M into R between C with M into standard deviation of B into standard deviation of C. Okay. It is provided as 0.95, 0.75, 0.95, 0.75 into standard deviation of B and standard deviation of C. That is 18 and 12. That comes to 153.9. This is the way the covariance between A with B, A with C and B with C can be calculated. Now finally, we understand that say if at all we want to compute the covariance of A with A, for example, then in that case how we can calculate the same? It is correlation coefficient of A with A into standard deviation of A into standard deviation of A. Correlation coefficient of A with A is of course 1 into standard deviation of A is 20%, so it is square of 20. So into 20 into 20, that comes to 400. So covariance of A with A is nothing else but it is the variance of A. That is what we understand. So it is A, B and C. Understand carefully. A, B and C. Variance of A is the covariance of A with A itself. A itself. So 20, 18 and 12. So it is 20, 18 and 12. Okay. So square of 20, square of 18 and square of 12. That is what we understand. Square of 20 is 400. Square of 18 is 324. Square of 12 is 144. That is what we understand. Next is the covariance between A and C is 108. So A with C 108. B with C 153.9. I'm sorry. A with B I forgot to write 205.2. This is 205.2. And B with C it is 153.9. So this is 153.9. This is the way the entire the matrix can be prepared. It is what we understand is the covariance matrix. A with A, A with B, A with C, B with B, B with C, C with C. Of course, we don't have to write anything over here because it is going to be repeated. That is B with A, okay, B with A would be 205.2. C with A will be once again 108 and C with B will be of course 153.9. So write on this final table. So I give a quick revision of the entire answer. Basically, we are required to make the computation of this, that is in this question, covariance. For that, so the formula that we are going to use is R is equal to covariance of A with B divided by the respective standard deviation. So this can be found as balancing figure as R into standard deviation of A into standard deviation of B. that is multiplication of this three value. Okay, now R of A and B have not been given, but R between A and M and B and M have been given to us. So what we are doing, we are multiplying this two value for the purpose of making this calculation. That's it. This is what say we have done. So for the others also, for making calculation of the covariance. Next is for calculation of the covariance of A with A. It is nothing else but it is the variance of A. This is what we understand.